This is Stacy, a student of Italian and a notorious napper. We're gonna watch her brain in action as she does homework. Well, that'd be kind of boring and complicated, so let's just pretend that a bunch of socks are the neurons in her brain. Okay, here we go. Stacy's brain has many specialized areas. There are visual areas like V1 or primary visual cortex, V4 and the inferior temporal cortex, decision-making areas like prefrontal cortex, movement areas, language areas like Broca's area, emotion areas like the amygdala, memory areas like the hippocampus and other diffuse long-term memory structures, as well as many, many others. Now let's see how these different parts work together.
Come si chiama questo rottaggio? Sergeant, what are we dealing with here? Ladies, what can you see?
Early visual areas analyze the world one little piece at a time. The little parts that each neuron can see are known as their receptive fields.
What is that? Do you see orange? I see orange. Oh, emerald fields. I see green. It's orange! It's green and kind of pointing to the right.
These different pieces of information move along to higher order visual areas that can then analyze more complicated features, like shape.
It's triangly and orange, and there's a little green poof, but it's mostly orangey though.
Eventually, enough information is integrated, and we can find neurons that can actually recognize whole objects.
Alright, it looks like we're dealing with a carrot at 45 degrees, sir. Good work, Sergeant!
Meanwhile, language areas, such as Broca's area, translate the answer into Italian.
Carota.
Carota!
I remember Grandma's carrot soup, it was so delicious!
Finally, prefrontal cortex decides what to do.
Motor Ninja, write that down!
It can issue commands to motor areas, such as write down the answer.
Hey, ningen o kakuzo!
Carota!
But sometimes, even neurons get confused.
Come si chiama questo animale? What is the name of this animal?
Especially when they get sleepy.
I'm a busy man, Sergeant. What's the holdup? Ladies! Oh, yes, Sergeant.
Yes, sir.
What? Oh, him again. What do you want now?
You're making us look like a bunch of slackers. For the love of the brain, what are we looking at?
It's orange. Black. Oh, this time I see yellow.
Yeah, well, I kinda see it. It's kinda orangey. Your information is conflicting and does not compute.
What's going on down there? I don't know what that is.
As Stacy falls asleep again, her thalamus, a very old structure in the brain, sends out waves of electrical activity, causing the cortical neurons to oscillate slowly and synchronously. Now it looks like she's entering REM sleep. This is characterized by very fast neural activity that is similar to the waking state.
Orange. Black.
Carrot?
REM stands for rapid eye movements, and it's associated with dreaming.
Carrot?
Orange left! Black!
President, sir, it's a tiger, sir.
Well, of course it's a tiger. Anyone could have seen that.
Tigre!